Maths. It's full of numbers, but some numbers are more than just numbers, they're ideas. And some of those ideas that are a bit weird. Dr. Constant, thank you for being here to talk about the number E.
It's a pleasure, though it's usually written in lowercase e.
Right, because it's shy. So E, it's a number, you say. What number is it? Is it 3?
Not quite. It's approximately 2.71828, but it's what we call an irrational number. It goes on forever without repeating.
Forever? Like that song by Rick Astley. So it's a number that can't make up its mind what it is. It's a bit of a mess, really. What's it for? What's its job?
Well, it's fundamental. It's the base of the natural logarithm for a start. It's the rate of growth if something grew continuously, like a bank account with compound interest calculated every single instant, or a population of rabbits that could have babies at any time, not just in spring.
So it's for rabbits and bankers, the two pillars of society. When you say continuous growth, do you mean like a mould on cheese that you forget about at the back of the fridge until it's taken over the vegetable drawer and is thinking about applying for its own mortgage?
That is a surprisingly apt analogy. Yes, that relentless exponential growth is described by E.
And this natural log you mentioned, is that like a piece of wood you find in the forest that has the number E carved into it by fairies?
Logarithm. No, it's a function, the inverse of the exponential function.
So it undoes the growth like a diet after Christmas.
In a manner of speaking, it helps us find the time it takes to grow to a certain size.
Right. So if my cheese mould wants to know how long it's been since it was just a harmless bit of cheddar, it would ask E.
It would use the natural logarithm, yes.
And they found this number. How? Was it just lying there, waiting to be discovered, like America?
In a way, it emerges from the study of calculus. If you take the function e to the power of x, its derivative is itself. It's the only function that does that.
Its derivative is itself. So it's a bit up itself, isn't it? Very self-involved, narcissistic even.
I wouldn't assign it personality traits. It's a mathematical constant.
But it's everywhere, you say, like CCTV or that Baby Shark song. They call it natural. But is it? Is a number that describes infinite growth natural? In nature, things stop growing. Trees don't punch through the atmosphere. Rabbits eventually meet a fox. My cheese mould eventually gets discovered and thrown in the bin by my mum. So isn't E a bit unrealistic? A bit of a fantasist?
It describes the idealized growth, the underlying principle. Reality imposes limits, but the engine of that growth is E.
So it's the dream of growth, the ambition of the mould, I say. And this number, does it have any famous friends? Or is it a loner, like the number 1?
It has a very famous friendship, actually. It appears in what many consider the most beautiful equation in mathematics, Euler's identity. E to the power of I pi plus 1 equals 0. It links E, the imaginary unit, I, pi, 1, and 0.
So it's in a band, a supergroup, with a made-up number, I, and its old mate pi from circles, and the two most basic numbers, 1 and 0, and they all get together and make nothing. 0. After all that, they cancel each other out. It sounds like a complicated way of saying nothing, like a politician's speech.
It's considered a pinnacle of elegance and interconnectedness.
So, to sum up, E is a messy, never-ending number that's a bit full of itself. It's the dream of mould and money. It hangs out in a supergroup that achieves nothing. And it's somehow the most natural thing in the world. Have I got that right?
In the most horrifyingly reductive way possible, yes.
There you have it. E, the number that proves that even in maths, the most sensible sounding of subjects, things can get properly weird. Now, about this imaginary number friend of his. Does it actually exist? Or is it just maths having a lie?